You've been waiting for the day, and it's finally here. It's time to learn about the chain rule. So, the chain rule lets us put a function inside of another function and be able to take the derivative of it. So what we're going to do for the derivative in the chain rule is that we are going to work from our outermost function into our innermost function. So we are going to start with our outermost derivative of the inside function, and then we're going to move on to our innermost function's derivative. So the way that I'm going to state it is the outside derivative of the inside function times the derivative of the inside part. And so what we're going to end up doing is you're going to have a function inside of another function, inside of kind of a larger function, and we're going to worry about that larger function's derivative first, the outermost function's derivative first, and we're going to keep the inner function how it is. Then we're going to multiply all that by the innermost derivative that we had kept how it was. Let's look at an example, because that's going to, I think, make it clear. All right. Y equals 3x plus 2 quantity to the 5th power. So we have two different ways of taking this derivative. Either we can expand 3x plus 2 to the 5th, which you can do that. That's doable. If I gave you about 20 minutes or so, you'd be able to do it, and then it'd just be a power rule. But for the chain rule, we're going to have an innermost function, which I'm going to put in red, and then we have an outermost function. So there's something happening to that inner function. In this case, it's being raised to the 5th power. So y prime is going to be, we're going to deal with taking the derivative of the outermost function first. So I have something to the 5th power. If I take something to the 5th power, then the derivative of taking something to the 5th power would be bring the 5 out in front, and then the exponent, we would subtract 1. So instead of being to the 5th power, now it would be to the 4th power. So 5 times my function to the 4th. What's my function? Well, my innermost function is 3x plus 2. So that is my outside derivative, derivative of the outermost, of the inside function. Inside function stays how it is. Then we're going to multiply by the derivative of the inside part. So times the derivative of the inside part, derivative of 3x plus 2, well, derivative of 3x is just 3. And then derivative of 2 is 0. So the innermost derivative is just 3. So I can actually multiply 5 times 3, and that's going to equal 15. And then we have 3x plus 2 to the 4th. Much easier than expanding all of that out. That's our final answer. Next. Once again, our outermost function is cubing this time. Our innermost function inside the parentheses is a 3x minus 2x squared. So f prime of x. We'll start with our outermost derivative. Our outside derivative is going to be cubed. Derivative of cubed is 3 times the thing squared. That's our outside derivative. Of the inside function is 3x minus 2x squared. So here the innermost function stays how it is. Times the derivative of the inside part. Derivative of 3x is 3. Minus derivative of 2x squared, that's going to be 4x to the first. So we could rearrange that order, we could distribute, we could do a couple things, but I'll leave it as 3 times 3 minus 4x times 3x minus 2x squared. Questions so far? Let's do some more of these. X cubed minus 6 to the 3 halves. So our innermost function is still x cubed minus 6. Our outermost function now is to the 3 halves. So first off, to the 3 halves, if we take something to the 3 halves, then our derivative would be, bring the 3 halves out in front, subtract 1 from the exponent. So we'll keep that innermost function how it is. Times the derivative of the inside part. Derivative of x cubed minus 6 is going to be what? 3x squared. So outside derivative, 3 halves, and then subtract 1 from the exponent, of the innermost function, the x cubed minus 6, times derivative of the inside part. Derivative of x cubed is 3x squared. So remember, we don't take the derivative of the inner part until we've dealt with the outer part. So we don't take derivative inside of here. We take it separately, multiplied out here. If we wanted to rewrite it as square roots and multiply that out, we could write it this way as well. A lot. So I was just getting to the question of how are we supposed to write them. It just depends on what we're looking for. There are certain type of questions that might be easier to answer for us or easier to simplify one way or the other. There might also be a multiple choice. You might get it as a multiple choice question, and this answer choice is not there, but this one is. So you should be able to recognize and be able to pick out which one it simplifies to. But if it were a free response and it just asked for the derivative, it would take either of those two answers. But you should be able to recognize different forms, and different forms might be more useful. For example, if I asked you what the domain was, I'd rather answer a domain question down here than up here. Easier to notice quickly what's causing the domain restriction, which is the square root. Try the next one. Answer. So 1/2 times x squared plus 1 to the negative 1/2 times derivative of the inside part. Derivative of x squared is 2x, and then derivative of 1 is 0. So what I did to simplify here is that I have a 1/2 here and a 2 on top here, so I cancel them out. the x is on top, and the negative exponent tells me it moves to the bottom, to the 1/2 tells me square root. X squared times the square root of 1 minus x squared. Oh, times, that means we're looking at a product rule. So let's see. We have these are my two functions that we're multiplying together. First times derivative of the second plus second times derivative of the first. First, x squared. Easy. Times derivative of the second. Here we go. Derivative of the second. Derivative of square root of 1 minus x squared. Well, derivative of a square root, so that's to the 1/2, is going to be 1 minus x squared to the negative 1/2. So that's my derivative of square root. Sorry, it should be 1/2 out in front. And then don't forget that after you've done the derivative of that square root, after that you also need to multiply by the derivative of the inside part. That's the important piece of the chain rule that's easy to miss. Derivative of 1 minus x squared, derivative of 1 is 0, minus derivative of x squared is 2x. That's our first times derivative of the second. Plus second times derivative of the first. Derivative of x squared is 2x. So let's do a little bit of simplifying here. We can do actually quite a bit of simplifying, but I'm just going to keep it to the bare bones. These 2's are going to cancel. I'm going to say x squared times x. It's going to be a negative x cubed. And then I'm going to put that over my square root of 1 minus x squared. And then I have plus, there's a 2x times square root of 1 minus x squared. I could simplify it more, but I'm going to leave that how it is for now. We could write this all under one big fraction. But that's more of an algebra 2 problem and less of a calculus problem, so I'm going to focus on the calculus part of the problem. Next. We good to go on? Okay. Oh, there's all the simplifying. You can multiply on top and bottom. All right. Oh, a homework assignment. How'd that get there? Here we go. This is where we need to start to really be comfortable with those derivative rules we talked about last time, because we're going to use them in much larger derivatives here. This is a quotient rule. So we're going to do low d high minus high d low over the square of what's below. Low d high, derivative of x, is 1. Minus high d low. This is x squared plus 4 to the what power on the bottom? 1/3. So we're going to say that it's 1/3 times my innermost function, x squared plus 4. To the negative 2/3. Over the square of what's below. Oh, we got to multiply. So this is the easy part of the chain rule to miss. Don't miss it. Don't rush through and get your outermost derivative without multiplying by the derivative of the inside part. Make sure you don't miss this multiplying by that derivative of the inside part. That's the key part of the chain rule that's really easy to miss, especially when you're doing it in a larger derivative. You're going to hear me yelling about it for the rest of the semester. Square what's below. Okay, this one we're going to simplify a little bit. Squared. Okay, so far with that? That's just rewriting all the exponent stuff. And multiplying the x times 2x. So now, I will ask that if there's a fraction and a fraction, that we get rid of that. So I'm going to multiply top and bottom. All right. So over here, well, first of all, on the bottom, we're going to have the cube root of x squared plus 4. This was squared and this was squared, so now it's going to be on the bottom to the 4th power. On the top, something interesting is going to happen here. I got a cube root squared and then a cube root to the 1st. So a cube root squared times cube root to the 1st, that's going to be a cube root to the 3rd, which will make the cube root be gone. I got an x squared plus 4 to the 1st power, to the 3/3 power. Then these cancel. So this will end up canceling. So we'll just have a minus 2x squared. So finally, to the 4th on there, I got an x squared minus 2x squared, so that's going to be a negative x squared plus 4. Oops. Made it look like an equal sign. I would argue that you definitely would want to simplify. This is a much nicer function to work with than this thing or this thing. So, you want the time you get out to be benefiting the time that you're putting into simplifying. And I would say this is worth the time to simplify. Questions so far there? All right. I will give you a minute's head start on this one. I want to see what you can do with it. So the last one had a chain rule inside of the quotient rule. This one's the other way around. This one has a quotient rule inside of the chain rule. So in other words, when we do the derivative of the inside part, that inside part is a quotient rule. So the outermost function is squared. So we start with that. There's a 3x squared from here, and then a minus 6x squared from here. That's where the negative 3x squared comes from. Then you have a minus a negative 2x, so plus 2x. Then I have 3 times 3 is 9 from here. Like I said, we have an x squared plus 3 cubed from multiplying these on the bottom. And then distribute. Here's all the distributing fun. We combine some like terms together.